Welcome to polynomial functions.
Our main goal in this section is to learn how to graph polynomials. So let's look at graphs of polynomials versus non-polynomials. The first graph that we have pictured here is the graph of a polynomial. Notice that it's a 7th degree trinomial. Also notice that it's a nice, smooth, continuous curve that extends from negative infinity to positive infinity. Now let's compare it to two non-polynomials. Notice that we have here h of x equals 2 over x plus 2. This is a non-polynomial because we have an x in the denominator. Let's look at the graph. Notice that the graph is a nice smooth curve, but it's not continuous. There's a break in the domain right here at x equals negative 2. So this is not a polynomial. Let's look now at the third graph. This third graph is g of x equals 2 times the absolute value of x minus 2 plus 2. You can see that the equation does not fit the characteristics of a polynomial, but just look at the graph. Now the graph is continuous, but it's not a smooth curve. Notice that there's this sharp corner here. One important trick that we can use to help us graph polynomials given their equations is the leading term test. Notice here we have the leading term a sub n x to the n. The leading term test helps us to know where the graph is going as x is going towards positive infinity and as x is going towards negative infinity. Let's look at this first one. If a is greater than 0 and n is even. So if a is greater than 0, that would be a number like 5. And then we have x to the n is even. We could just say 2. So this is 5x squared. This has these characteristics here. Well, the end behavior of the graph, you're going to have arrows pointing up in the first quadrant and in the second quadrant. It's going to be doing other stuff here in the middle, and you may have, other stuff added or subtracted here. You could have like 2x added and then a minus 1 or something like that. But the leading term is 5x squared. That dictates the end behavior. Okay, so it's going to have arrows pointing up in the first and second quadrant. If a is greater than 0 and n is odd, like for example, if you have, 5x cubed instead, and then you could have some other stuff added, but 5x cubed, then in the first quadrant, your arrows are going to be pointing up, and in the third quadrant, they'll be pointing down. And if you have a less than 0, so if you have a negative, let's say instead we have negative 5 and x, instead of squared, we can put, it just has to be an even number. Even if you have 100 here, that's an even number. Okay. And then you could just put plus 1 or something. You're going to have arrows pointing down in the fourth quadrant and then the third quadrant. And then we have our fourth case here. If a is less than 0 and n is odd, so let's say this time we have negative 5x to the, let's just pick any odd number. We can just pick 7. And then, plus whatever we want to add. It doesn't matter what's added or subtracted after that. But again, the point is this negative 5x to the 7th. The end behavior that you're going to have is in the second quadrant, right here, you're going to have arrows pointing up. And in the fourth quadrant, it's going to be pointing down. So that will help us in a second when we get to graphing some of our polynomials.